Math Buhay! And welcome to DepEd TV. This is Mathtivated for Grade 11 General Mathematics. I am Teacher Carol, and there's nothing too big or too small because we will learn it all. So keep Mathtivated and stay with me because we are together in this wonderful journey. It is nice to see you again, my Mathtivated students. How are you doing? If you are keeping that Mathtivation to learn every day, it is a job well done. Let us grow your Mathtivation as we take another lesson today. Before we have that, let us take a look at these words or phrases. We have lit, Lodi, ghosting, Gina G, and OMG. Are you familiar with these words or phrases? Have you used them? The creativity of students nowadays brought them to creating and using terminologies like this in communication. And these are just some of the many expressions we used instead of the original terms. It is nice to see how creative students are, even in communication. But let us be reminded of the power of a person's words. For it is said that a person's words can be life-giving water. Words of true wisdom are as refreshing as a bubbling brook. Let us always be careful and think before we speak. Like in communication, where a word can be represented using other expressions, in math, there are also expressions that have different representations, and we will deal with one today. Last time, we had a discussion on exponential expressions. We know that these expressions can be represented through logarithms. And this time, we will focus our discussion on distinguishing logarithmic function, logarithmic equation, and logarithmic inequality, and solving logarithmic equations and inequalities. Already Mathtivated? Let us start. What can you remember about logarithms? We mentioned that exponential expressions can be represented as logarithms. Suppose we have 5 squared equals 25. How can we represent this using logarithm? This can be represented as the logarithm of 25 with the base 5 is equal to 2. Let us try the second example. We have 2 raised to 3 equals 8. How do we write this using logarithm? This is equal to the logarithm of 8 with the base 2 equals 3. How about this third example? This one can be expressed as the logarithm of y with the base p equals x. What can you notice about these examples? How will you describe a logarithm? A logarithm is an exponent which the base p must have to produce y. Now that we have recalled what logarithms are, let us have logarithmic equations. What can you remember about logarithmic equations? Let's try identifying which among the following is a logarithmic equation. Let us check your answers. For x minus 2 all over 2x equals 4, this is not a logarithmic equation. This is a rational equation. Great job! It is nice to know that you still remember our previous lesson. How about this expression? Very well! This is not a logarithmic equation, but an exponential equation. Let us check this expression. This one is a logarithmic equation. So when is it a logarithmic equation? A logarithmic equation is an equation that involves a logarithm of an expression that contains a variable. While a logarithmic inequality is an inequality containing logarithms in one or both sides of the inequality. These are examples of logarithmic inequalities. We have 4 is less than the logarithm of x with a base 10. Another example is the logarithm of 36 with a base 6 is greater than or equal to the logarithm of x with a base 6. The logarithm of the quantity x plus 1 with a base 3 is greater than 3 is also a logarithmic inequality. Now that we have learned what logarithmic equations and inequalities are, let us check on logarithmic functions. A logarithmic function is a function of the form y equals the logarithm of x with the base b. Suppose we have y equals the logarithm of x with the base b. In exponential form, this is x equals b raised to y. If you will notice, this is the inverse of the exponential function y equals b raised to x. Since we have a restriction that b should be greater than 0 and not equal to 1 in an exponential function, we also have the same restrictions for the base of the logarithmic function. Hence, a logarithmic function is a function of the form y equals the logarithm of x with the base b, where b is greater than 0 and not equal to 1. We just have finished distinguishing logarithmic equations, logarithmic inequalities, and logarithmic functions. That is a job well done! Let us now try to solve logarithmic equations and inequalities. Suppose we have 3 times the logarithm of x with the base 2 is equal to 9. The first step that we'll have to do is to isolate the logarithmic term on one side of the equation. Since the logarithmic term is already isolated on one side of the equation, we simplify by multiplication property of equality. We multiply both sides of the equation by 1/3. 1/3 times 3 times the logarithm of x with the base 2 is equal to the logarithm of x with the base 2. We then multiply 1/3 to 9. This gives us 3. We now have the logarithm of x with the base 2 is equal to 3. The next step is to write the equation in exponential form. This can be written as 2 raised to 3 equals x. We then solve for the variable x. 2 raised to 3 is the same as 2 times 2 times 2, and that is 8. Hence, we say that x is equal to 8 and 3 times the logarithm of 8 with the base 2 is equal to 9. Let us check it using the calculator. Again, we have 3 times the logarithm of 8 with the base 2 equals 9. To have it using a calculator, we press 3, then logarithm, press the base 2, we then move the cursor to the right, and we may press 8. Let us now press equals. What did you get? Did you get 9? Well done if you did! Let us have the second example. Let us take 4 plus the logarithm of the quantity x plus 1 with the base 3 equals 7. Again, we isolate the logarithmic term on one side of the equation. By addition property of equality, we add negative 4 to both sides of the equation. That gives us 4 plus the logarithm of the quantity x plus 1 with the base 3 plus negative 4 equals 7 plus negative 4. 4 plus negative 4 is 0, while 7 plus negative 4 is 3. The next step is to write the equation in exponential form. This can be written as 3 raised to 3 is equal to x plus 1. We may now solve for x. 3 raised to 3 can be written as 3 times 3 times 3, or simply 27. Now, we have 27 equals x plus 1. By addition property of equality, we add negative 1 to both sides of the equation. That is 27 plus negative 1 equals x plus 1 plus negative 1. 27 plus negative 1 is 26. 1 plus negative 1 is 0. Thus, we have 26 equals x. Hence, x is equal to 26 for the equation 4 plus the logarithm of the quantity x plus 1 with the base 3 equals 7. Let us check it using the calculator. For the logarithmic equation, 4 plus the logarithm of the quantity x plus 1 with the base 3 equals 7, we press 4, then plus, followed by the logarithm, then 3 the base. We adjust the cursor and press 26, followed by plus, then 1. We may now press equals. Did you get 7? Great job! Let us now try to solve logarithmic inequalities. Let us take the logarithm of x with the base 6 is less than or equal to 2. In exponential form, it is written as x is less than or equal to 6 squared. 6 squared is 36. The logarithm of x with the base 6 can be written as 6 raised to y is equal to x. We have learned in our previous episode that the values of x will always be positive, since the base of an exponential function is always positive. Thus, given the logarithm of x with the base 6 less than 2, x is greater than 0 but less than or equal to 36. Let us take value less than 36 and check it using a calculator. Suppose we take 35. Let us check it using the calculator. We press logarithm, then 6. We adjust the cursor and press 35, a value less than 36, followed by equals. Did you get a value less than 2? Very well! Now try having 36 as the value of x. Use your calculator. Go! What did you get? Did you have 2 as the answer? You are doing pretty well. Let us now try 0. What did you get from the calculator? Did it say math error? Again, we only take positive values of an expression. In this case, x. Are you still motivated? Let us solve another logarithmic inequality. Let us try solving the logarithm of the quantity 2x minus 1 with the base 5 less than the logarithm of the quantity 4 plus x with the base 5. If you have noticed, these terms have the same basis. Let us rewrite this as an exponential expression. We will have 2x minus 1 is less than 5 raised to the logarithm of the quantity 4 plus x with the base 5. Recalling the properties of logarithm, we know that if we have a raised to the logarithm of x with the base a, that is simply x. Hence, 5 raised to the logarithm of the quantity 4 plus x with the base 5 is simply 4 plus x. We now have 2x minus 1 is less than 4 plus x. We may now solve for x. By addition property of inequality, we isolate the variable on one side of the inequality. We will have 2x minus 1 plus negative x less than 4 plus x plus negative x. Combining like terms, we will have x minus 1 is less than 4. By addition property of inequality, we add positive 1 to both sides of the inequality. That is, x minus 1 plus 1 is less than 4 plus 1. We combine like terms, and this gives us x is less than 5. A while ago, we have learned that the logarithm of an expression, the expression should be greater than 0. Thus, we know that 2x minus 1 and 4 plus x should not be equal to 0. Now, we also consider values of x that will make each expression greater than 0. Let us have 2x minus 1 first. This expression has to be greater than 0. We may add positive 1 to both sides of the inequality. This gives us 2x minus 1 plus 1 is greater than 0 plus 1. Adding like terms, we will have 2x is greater than 1. By multiplication property of inequality, we multiply both sides by 1/2. This gives us x is greater than 1/2. Thus, we consider values of x greater than 1/2. Let us now have 4 plus x. Again, this has to be greater than 0. We isolate x on one side of the inequality. By addition property of inequality, we add negative 4 to both sides. That is, 4 plus x plus negative 4 is greater than 0 plus negative 4. Combining like terms, we will have x is greater than negative 4. Now we consider the following conditions. X is less than 5 based from the solved logarithmic inequality, and x is greater than 1/2, and x is greater than negative 4 based from the restrictions for the logarithms. We take values of x considering all these conditions. That means we take the intersection of these sets. Let us use a number line for better illustration. For x is less than 5, those are these values highlighted in red color. For x is greater than 1/2, these are values in green color. For the third condition, x is greater than negative 4, these are values in blue. If you have noticed, the intersection of these lines are values from 1/2 to 5. And we take these values as the set of solutions for the inequality. The logarithm of the quantity 2x minus 1 with the base 5 is less than the logarithm of the quantity 4 plus x with the base 5. Thus, x is greater than positive 1/2 but less than positive 5. You can check values of x using your calculator. Good job! We were able to distinguish logarithmic function, logarithmic equation, and logarithmic inequality, and solve logarithmic equations and inequalities. Let us discuss more by posting the things you learned today or the challenges that you encountered. Use your social media accounts and use the hashtag MathEvatedE8. Let us enjoy learning more and be motivated to embrace new challenges for us to grow. I had fun being with you, my motivated students. I hope that you also did. Again, this is Teacher Carol, reminding you that what others can do, you can too. So let's grow our efforts for us to grow our skills and knowledge. See you in our next episode.